Greetings, mathematicians. This is Mrs. Mounts, and today I'm going to go over how to calculate exponential growth and exponential decay with an equation. But first, here we go. All right, that one was pretty predictable. Okay, let me get my computer set up here, and we'll go over a few things for the notes. All right, there we are. Okay, so we're first going to talk about exponential growth, and this is a great example if checking or bank accounts would have pretty good interest rates. Right now, they're not the greatest, but you know what? CDs are good right now. Maybe the stock market, mutual funds, all that kind of thing. As you get older, you'll probably want to start investing your money. So this is just an example. We have $500. You have an annual rate of 2%, and you're just going to leave that in for 50 years. So let's see how much interest we would actually earn and what it would be worth at the end of that 50 years. So the first thing we're going to do is figure out what our initial amount is, and that would be the 500. The rate is 2%. Now, one thing that you need to do with that is you need to put it as a decimal. So 2%, we would move it 2 to the left, 1, 2. So 2% would be 0.02. So anytime you're using rate in a formula, we do change that to a decimal. And then T stands for time, and that would be 50 years. So we're going to plug it into this formula. Exponential growth is where we add the rate, okay, which will probably make sense here. We'll show you. So our amount would be the $500, the initial amount, parenthesis 1 plus 0.02, that's our rate, and then our time is 50. So we're going to use a calculator definitely for this, okay? I couldn't even do this one mentally for sure. Now I can do this little part. 1 plus 0.02 would be 102%. Hopefully that makes sense. So that 1 means 100, the 0.02 is 2%. So 102% raised to the 50th power. Now we're definitely going to type that in. Okay, I'm going to hit clear here. 500, parenthesis 1.02, close it up. Now to get an exponent, I am going to hit that up arrow key. I call it the caret key or the power key. So I'm going to hit it there and type in 50. That's all you have to do. So once you plug it in, use your calculator, and there's our answer. So I am getting a value of $1,345, and I'll just round it here in 79 cents. So that's what it would be worth. Now, if we wanted to actually know, okay, so how much interest did we earn, we would just subtract off the initial $500. So let's see. So that just sitting there for 50 years earned $845.79. So not a whole lot, you know. You would probably want a little bit better percent if you were actually going to save up money for that many years. But it just gives you an idea of what would happen if you were just to leave it in the bank. Okay, decay. So now decay, if you look at the equation, we're going to subtract the rate because things will be disappearing over time. So here's an example. You have a child that's taken 200 milligrams of amoxicillin. Now, this is just, I don't know if this would be true or not. That's why you always want to follow medication guidelines. For this example, each hour the child is losing 25%. So how much amoxicillin would be left in a child after 12 hours? We have our initial amount is 200. The rate is 25%. So again, we're going to move it 2 to the left. 25% is 0.25. And then the time, sometimes time can be years, it can be hours. Well, this example, it's going to be hours. So over a 12-hour time, how much would you still have left in that child's system? Here's our formula. We'll go N equals, the initial amount is that 200 milligrams, 1, which stands for 100%, minus our 0.25, raised to the 12th power. That would be T in time. Rate is our percent. So again, I'll simplify this. 1 minus that 25% would leave us 0.75 over that 12-hour range. So I'm going to hit clear on my calculator. Let's go ahead and type that in. So I type in 200, parenthesis 0.75, close that up. We're going to raise it to the 12th power. So right there's that caret key. It's kind of diagonal from the 7. And then we type in 12. We hit enter. And so only after 12 hours, that child has 6.3, approximately 3.4 milligrams of that amoxicillin still in their system. So you can see, like with a prescription, you want to keep up with that. Eventually, you know, you would lose some of that. So maybe this particular prescription, you're going to take it every 8 hours. Who knows? That's why, like, when you take Tylenol or you take ibuprofen, they want you to take 2 every 4 hours. Once that wears off, well, then your fever raises or your body starts aching. So that kind of makes sense. One other thing I want to talk about real quick before you glue this in is a coin. Okay, a coin or a two-sided chip. What is the probability that you would flip a coin and it would turn up heads? Well, it's 50-50. That's what a lot of people say. Well, we could say 1/2, or as a percent, it would be 0.50. So a lot of different ways. If we were doing a lab, this is what we would want to use. A dice. Let's talk about a dice. A dice is 6-sided. We would have a 1 in 6 chance of, say, flipping a 2. A 1 in 6 chance. I'm going to use my calculator here and see what that actually is. 1 divided by 6. So it's approximately 0.17. That's what we would use on the data sheet. Okay, so just kind of some things that we'll be doing on a lab, and you may need those particular numbers to help you on the lab sheet.